a book entitled Toward the Year 2018. Chapter 5 was written by Thomas F. Malone. And Thomas F. Malone was the chairman of the Committee on Atmospheric Sciences of the National Academy of Sciences and vice president and director of research of the Travelers Insurance Company. This book was published back in the 60s. How man will control the weather. At the risk of oversimplification, and with the usual caveats about fallibility, the present position and some judgmental evaluations of the future prospects for weather modification can be summarized as follows. Number 1, field results have demonstrated unequivocally that several cubic miles of supercooled clouds, liquid cloud droplets at temperatures below freezing, can be transformed into ice crystal clouds by seeding with appropriate chemicals. The technology for performing this kind of weather modification will be perfected rapidly over the next decade. Number 2, dissipation of supercooled fog over an airfield runway is now operationally feasible and has been used to good economic advantage by airlines in the United States and in other nations. Further improvement in technique will likely affect only the economics, not the efficacy of this control measure. Number 3, recent experimentation in clearing certain types of warm fog, that is, droplets at temperatures above freezing, over airports is beginning to provide encouraging results. An important breakthrough in this type, highly localized weather control, is likely to be realized in a matter of years. Number 4, relatively little serious attention has been given to conscious interference of the processes at the interface between the atmosphere and underlying surface beyond demonstrating that it is possible to inhibit evaporation from water surfaces and vegetation. If, as it now appears to be likely, these interface processes turn out to be important to large-scale modification of the climate, there is a high probability that the techno-something could go through explosive development in the period from 1975 to 1995. Number 5, persuasive, although by no means conclusive evidence, suggests that rainfall can be increased through cloud seeding by from 5 to 20%, say 10%, depending on the conditions. There's a high probability that residual ambiguity will be resolved by 1975, and a further high probability that by 1980 naturally occurring rainfall can be either augmented or diminished locally by proved techniques. The probability is high that by 1990 rainfall several hundred miles downwind from the site of the operations can be increased or decreased at will. Number 6, there are indications that Soviet scientists have succeeded in reducing hail damage by a factor of from 3 to 5 by introducing silver iodide directly into susceptible parts of hail-producing clouds. This form of weather modification will probably always remain local, but will develop rapidly over the next decade, and there is a high probability that it will begin to be adopted for widespread use by the early 1980s. Number 7, physically reasonable approaches to the suppression of lightning have been tried. You'll have to excuse me, folks. I'm reading from not a very clear copy. Let me start this paragraph over. Number 7. Physically reasonable approaches to the suppression of lightning have been tried with what appears, on balance, to be promising results. Progress on this highly localized modification measure will be retarded pending a satisfactory explanation for the lightning discharge produced, but the probabilities are high that operational techniques will be available by the late 1980s. Number 8, cloud seeding techniques that are of sufficient merit to warn field experimentation have been advanced for the modification of hurricanes. The limited tests have not as yet yielded even preliminary conclusions. This approach should be pursued vigorously, but the probability of success is not high, only about 50%. New concepts are needed, and they are likely to emerge from computer simulation of hurricanes for 5 years are allowed for the development of an adequate mathematical model. 5 more years for assessing the consequences of intervention of various kinds, and then 10 years of field experimentation for validation. It seems unreasonable to expect much before 1990, with the probabilities fair to good that a proved technology will exist by the year 2000. Now, I have to interject something here, folks. If you've been listening carefully, you'll see that all the predictions were for the completion of this technology and for the ability to perfect weather control in the 80s and at the latest by 1990. Now, I want you to ask yourself, when did all the strange weather patterns begin? When did the crazy storms start to come? When did hundreds and hundreds of tornadoes hit the Midwest out of all reasonable expectations? When did the flooding and the unbelievable droughts and the fires take place? All after 1990. Number 9. No technique for consciously influencing large-scale weather patterns yet exists, and not much progress can be expected for another decade until the scientific results of the recently approved Global Atmospheric Research Program begin to be available. The 1970s should be a productive and exciting decade for basic research on the general circulation of the atmosphere. The 1980s and 1990s should be an equally productive period of experimentation by means of computer simulation on the technology of large-scale climate modification. The probability of success in broad climate modification is likely to exceed 50% by the year 2018. Man will control rain, fog, storms, and even possibly the climate, by Thomas F. Malone. This is chapter 5 in the book entitled Toward the Year 2018. In retrospect, it is clear that our approach to the problems posed by nuclear energy and space travel, which have so dominated our thoughts in recent years, has been limitedly one-sided. Although we poured truly stupendous resources of time, brains, and money into developing the technologies of these two fields, somehow we never got around to giving much consideration to the international implications of what we were doing. Had we done so, mankind might have managed certain crises of the past few decades with more wisdom and foresight, and correspondingly, the world outlook for the next 5 decades might not be so somber. Let us not make the same mistake in the field of weather and climate control. I believe the next 50 years will be crucial in the development of the technologies necessary for controlling, to a significant extent, this particularly sensitive part of our physical environment. But the coming half-century will also be crucial in a much broader sense. It will be a testing period for our society. A testing period for our society. A chance for us to fashion in advance a milieu in which technical advancement can take place in the service not of narrow national aggrandizement, but of all mankind. To achieve this in regard to weather control, several steps will be required. We must deepen our understanding of the scientific problems the opportunities it brings within reach, the limitations it imposes, and we must perfect technological dexterity where it has been developed and develop it where it does not now exist. We must assess social and economic benefits and penalties and weigh trade-offs. We must ascertain the biological consequences of deliberate intervention in the physical environment involved in ecosystems. We must resolve legal and jurisdictional complications. Above all, we must set about the difficult task of creating or adapting the international institutions that will be required if understand, ladies and gentlemen. Let me read that last sentence again because it's extremely important that you understand that this is another potential manipulation toward world government. Above all, we must set about the difficult task of creating or adapting the international institutions that will be required if the potential hazards to international relations are to be avoided and the opportunities are to be seized. The need for cooperation is clear. The warning flags have already been hoisted. The modest hopes and the quiet concern of the scientific community are a matter of record. The subject has been explored in both the executive and the legislative branches of the United States government. More than a decade ago, John von Neumann called attention to weather or climate modification as the kind of technological development that must be mastered through a long sequence of small, correct decisions if our society is, in his words, to survive technology, pointing out that measures in the Arctic may control the weather in temperate regions, or measures in one temperature region critically affect one another, or another one quarter around the globe. Von Neumann concluded, all this will merge each nation's affairs with those of every other, more thoroughly than the threat of a nuclear or any other war may already have done. Similar views have been expressed by meteorologists in an invited lecture on weather modification before the 5th Congress of the World Meteorological Organization in 1967. Academician E.K. Fedorov, chief, and get this folks, chief of the Soviet Hydrometeorological Service remarked, quote, "It is not difficult to understand that the problem of transforming the climate on a world or regional scale is, by its very nature, an international one, requiring the united efforts and the coordination of the activities of all countries. Ever more rapidly, humanity is approaching the stage in its symbiosis with nature when it can turn to practical account all the natural resources of the earth, and when, as a result, it will become capable of thinking in terms of natural phenomena on a planetary scale. It is hardly necessary to prove that, in these circumstances, all mankind should regard itself as a single whole in relation to the surrounding world. There is no other way."